Hi everyone, so today we will solve a problem about DC shunt generator. So we have a problem. So an 4 pole 500 RPM DC shunt generator with 600 wave connected armature conductors of 10 ohms resistance at their terminal voltage of 200 volts. The armature resistance is 0.5 ohms and a shunt field resistance is 240 ohms. So determine the flux per pole. So first thing we're gonna do, so we need to draw the circuit diagram and also we need to write the given. So here is the circuit diagram. So we have the generated voltage, the armature resistance, and also the armature current, our shunt field resistance, and the shunt field current. We have our load, our voltage load, and the current in the load. So we have a given of P, which is the pole, the number of poles is equals to 4, and N is equals to speed, which is 500 RPM, and the Z equals to the number of conductors, which is 600. We have the resistance in the load, which is 10 ohms, and the voltage in the load we have 200 volts, and the armature resistance, which is 0.5 ohms, and the shunt field resistance, which is 240 ohms, and our unknown is the flux per pole. So our formula in getting the flux per pole is here. So we have the generated MF is equals to the pole times the number of conductors times the flux per pole, the N, which is the speed, over 60A, which is A equals to MP. So first thing we're gonna do, so we need to get the EG, which is, or the generated MF, because it is not given in the problem. So here we go. So we need to apply the KCL first. So KCL, so we have the IE equals IHS plus IL. So from the KCL, so we have current in nga IA, so equals to the current out is IL and the IH. So in getting the IHS, so we have the voltage load over the RHS, which is parallel man sila, so we need they have the same voltage. So we have our IL, also we have VL over RL. So we need to put this in here. So we have the IHS equals to VL over IH, so we need to put this. So we have a given of VL nga 200, we have the RHS, which is 240, and also the RL na 10 ohms. So we need to haplak the given here. So we have the 200 over 240 plus 200 over 10. So if we calculate that, so we have a result of IA, which is 20.83 ampere. So since na naman tayo IA, so we need to apply the KVL to get the generated MF, or the generated voltage. So we have the formula of generated MF. So we have the generated MF is equals to VL plus the IE times the RE. So na naman tayo mga given ani, so VL nata, IE, also the RE. So we need to put or haplak na lang. So we have the generated voltage is equals to 200 plus 20.83 times 0.5. So if we calculate that, we have the result of 210.415 so volts. So since na naman tayo given, so balik ta diri sa atong formula na EG is equals to PZ flux times N over 60A. So ito nang gamiton ang atong formula. So here, so we have the EG na to nga natay given nga 210.415, so times the pole, which is the 4 times 600 nga Z, and also the unknown na to times the speed over 60 of times 1, since simplex naman ni siya. So we have the multiplex of 1 and the pole is 2, which is wave, since wave ni siya, wave bond winding. So if we calculate that, you have a calculator like this, so you can shift calc. So we have the flux, which is flux per pole is equals to 0.2 Weber. So that's all for today. Thank you and God bless.